Look at this dull, dirty rock. On the surface, it's entirely unremarkable, but hidden deep inside the grain, it holds a material worth more than your entire house. We often picture gold coming straight out of the earth as shiny, ready-to-spend nuggets. The reality is far less glamorous. It almost always begins as ore, dense rock mixed with scattered, practically invisible specks of metal. This model illustrates the staggering math behind the extraction process. To acquire just a few grams of gold, mining operations have to dig up, process, and completely destroy 1 full ton of solid rock. That massive disparity creates the central engineering hurdle for the entire industry. You have to locate and isolate microscopic fragments of value trapped inside literal mountains of worthless dirt. A solid gold bar is never a natural occurrence. It has to be forced into existence through an extreme physical process of mass destruction and aggressive reduction. The reduction begins underground. To find the ore, miners dig cavernous tunnels, sometimes extending over 3 kilometers below the Earth's surface. Down there, the environment is incredibly hostile. The air is dangerously thin, temperatures soar, and crews use massive explosive blasts to violently tear the rock walls apart. Once that rough rock is hauled up to the surface factories, the heavy machinery takes over. Giant crushers repeatedly smash the heavy ore, turning solid boulders into loose gravel. From there, the gravel enters grinding mills. Heavy steel balls relentlessly pulverize the material until it is reduced to a completely fine, dust-like powder. Yet, even after applying massive mechanical force to obliterate the stone, the gold remains totally invisible to the naked eye. Physical force alone cannot isolate it. To separate the metal from the dust, processing plants shift to chemical manipulation. They use a highly controversial tool, cyanide. The chemical acts as a molecular magnet. Cyanide reacts exclusively with the invisible gold particles, pulling them from the useless rock. This reaction changes its physical state entirely. It becomes a dissolved liquid solution, flowing away from the dirt. But this chemical efficiency carries a severe ecological risk. Cyanide is incredibly toxic. Even a minor leak from one of these processing vats can poison surrounding waterways and devastate native wildlife. To extract something perceived as pure and incredibly valuable, humans must actively risk poisoning the earth it came from. Now, the metal is trapped in a toxic liquid. To recover it, the plants run the solution through activated carbon, a specialized sponge that traps the gold particles, allowing the cyanide water to be washed away safely. The carbon is stripped, and the resulting material is thrown into blazing furnaces. Subjected to temperatures well over 1,000 degrees Celsius, the extreme thermal force burns away the remaining rock and carbon impurities. The liquid metal glows bright orange, pooling in molds before it is poured out to cool. For the first time in the entire journey, it forms recognizable, solid gold bars. That intense application of heat is the precise moment the invisible, toxic chemical extraction finally yields a physical, tangible reward. Despite the tons of destroyed rock, the lethal chemicals, and the blistering heat, that newly poured bar is still not entirely pure. To reach perfection, it goes through one final atomic-level filter called electrorefining. This diagram shows how electric currents are passed through a gold solution, stripping away the absolute last microscopic impurities clinging to the metal. This electrical bath is what yields the final 99.99% pure product, the highest quality 24-karat gold material in the world. That shiny metal represents a massive volume of discarded earth, the precise application of lethal toxins, and hours of blistering fire. Billions of tons of gold-bearing ore still sit untouched deep within the crust. As long as the math of extraction remains profitable, industry will continue to move entire mountains for these microscopic specks.